Okay, we will solve the following exercise. Exercise is the number 2.33. In example 2.4, the coordinates of the fixed point A are 17 and 1 in feet. The driver lowers the bed of the truck into a new position in which the coordinates of point B are 9, 3 as well in feet. The magnitude of the force F exerted on the bed by the hydraulic cylinder when the bed is in the new position is 4,800 pounds. Draw a sketch of the new situation. Express F in terms of components. Alright, so we're going to start determining the vector using the coordinates that we have right here. So the coordinates for point A are just 17 and 1. In the case of B, we have 9 and 3. I don't know the direction of the vector yet. The way that I'm going to know that is by creating the vector taking into account the coordinates. So all I have to know is that the initial point is A and the final point is B for me to create the vector. Now, how is that? The vector is going to be equal to 9 minus 17 in the x direction, that means the j direction, plus 3 minus 1 in the, this is in the I direction and this is in the j direction. Alright, so 3 minus 1. Why is that? Because the final point is B and the initial point is A. So final minus initial, final minus initial. That's pretty much it. Now, the vector is equal to minus 8, the I direction, plus 2 in the j direction. Now, taking into account this information, I'm going to create a vector within my Cartesian plane. So right here we have x and y. Now, the vector is going to point towards this direction. Kinda. Why is that? Because right here we have 8 units and right here we have 2 units. Positive, negative. That is why this is in this position. Now, why am I doing this? Because I need the angle. Which angle? I don't know. We are going to call it, for example, beta. Alright? So, I'm going to explain later why I need this angle. Because we have the 2 cathetes of the triangle, this triangle, I'm going to use tangent, the trigonometrical identity, for me to determine the angle. It is basically easier. So the tangent of the angle beta is equal to the opposite cathetus 2 divided by the adjacent cathetus, which is 8. Right? That means that beta is equal to tangent to the minus 1 power of the same division. Right? Now, we're going to do this in the calculator. You have to make sure that the calculator is in degrees. So tangent to the minus 1 power of 2 divided by 8. This is equal to 14.0362. I always use 4 significant digits after the comma. Now, why I need this angle? Because I need the unit vector. A unit vector is a vector that points towards the same direction of the initial vector, but the magnitude is always 1. The unit vector is used for we to play with the direction of the vector without taking into account the magnitude, because it is always 1, so we can play with that. Mathematically speaking, we are going to use the unit vector for us to determine the final vector, taking into account the magnitude of 4,800 pounds, the ones that we have right here, right? But I'm going to explain that later. So now that we have the angle, one way for us to determine the unit vector is taking into account, for example, the unit vector of RAB is going to be equal to the vector RAB divided by the magnitude of RAB. In this case, I need the angle because the other way for us to determine the unit vector is by applying the cosine and the sine of the angle. This angle has to be the one that touches the x-axis, in this case beta. Remember that. Why? Because as well the unit vector of RAB is going to be equal to the cosine of the angle beta plus the sine of the angle beta. Of course, we have to take into account some different variations to this equation. The first one, as you can see, this is negative. That means that in the unit vector, this should be negative as well. Remember, all we have to take into account for when we talk about unit vector is the direction. So we must do it correctly. Now, this is negative, and this is regarding the x-axis, the cosine. That means that right here we have our first component. The second one is positive, and it is regarding the j component. Right there we have our unit vector. Now that I've explained the two methods for us to determine the unit vector, we're going to solve the exercise. Now, we need this, right? So, f in terms of components, we need the vector, f. We have the magnitude, right? The magnitude, right here we have it. And we have the unit vector. So we can solve this equation for this incognita, and that would be pretty much it. So the final answer is going to be RAB. The vector will be 4,800 pounds multiplied by minus cosine of 14.0362 in the I direction plus the sine of 14.0362 the j direction. Remember, when you multiply a scalar by vector, it is like you actually were doing a distributive multiplication. So the first by the first and then the first by the second. So the final answer will be RAB is equal to 4,800 multiplied by the cosine of 14.0362. And right here we have 4,656.0 6848. The I direction. But we have to take into account this minus, so minus. Plus the same equation, but I'm going to change this with a sign. 1164.1674, the J direction. And right here, guys, we have our final answer. So it is asking for the graphical representation, I think. Draw the sketch of any situation. Right here we have it. And express f in terms of components. Right here we have it as well. Right, guys, that would be pretty much it. All you have to take into account for you to solve these exercises are basically, and I can assure you this, these two equations. This one and this one. Right? That the camera was down. Okay, so that would be pretty much it. I'm sorry for the minutes with the camera. And this is how you can solve this exercise.